Previous video, we discussed about dimensional vector space. How gonna find the dimensional vector space? We need to find the base for the vector space. Number of vectors in the base gonna be dimension, right? So this section, we're gonna talking about how gonna find dimension of column of A, null of A, guys. Let's quick review what is null subspace or column subspace of matrix A. Matrix A, n by n matrix. So we're gonna define the null of A gonna be A times X gonna be zero vector. Zero vector, that's we call this is null space of A. Column of A meaning is you have X, put any X from the Rn, then you're going to do operation and find the B value. That's correct, all the B value. We're going to say that's going to be column of A, guys. So keep in mind the definition and how can find column and null space of A, guys. Let's use this matrix. What is the size of this matrix? 3 by 4 matrix. So we're gonna find the base for the null space, base for the column space. That's we're gonna do it first. We're gonna do the null space of A. So what is the definition of null space? AX gonna be 0. We're gonna find the X value, right? So you have matrix right there, guys. 1, 4, 2, 1, 0, 0, 1, 3, 0, 0, 0, 1. Guys, this is matrix A. So constant column gonna be 0, 0, 0, right? So what you see from here, x gonna be what? x1 plus 4x2 plus 2x3 plus x4 gonna be 0. That's the first equation from the low one. Second is gonna be x3 plus 3x4 equals 0. Fourth one is x4 equals 0. So x4 equals 0, which meaning is here, right here. Here is go to here. x4 equals 0, which meaning is x3 gonna be negative 3x4. That's gonna be 0. But right here, how many free variable? So x1, x2, x3, x4 gonna be 0. So you have x1, 4x2 equals 0. X1 is negative 4x2. So here is x2 is a free variable, right? So x2 is free variable. So you have find the x factor in the null space. So how can find the x1 is negative 4x2, x2, 0 and 0. This one gonna be x2. You're gonna find negative 4, 1, 0, 0. So what is base? Base for null space gonna be this vector. This vector is base, right? I'm gonna put this one is a v vector, okay? So v vector gonna be basis for null of A. Why did I say that? Because this one span X is null space, okay? Null space is linear combination of V vector. Yes, scalar multiplication, right? There is only one vector that's linearly independent. So you're gonna say this one is you have check null of A, span, and V vector. We check it. And V vector gonna be linear independent, of course. So you're gonna say what, guys? So dimension of null of A gonna be 1. Guys, make sense? That's how I find it. This one is the dimension of null space is 1. Okay, let's go. Another way you're gonna see, guys, another way I just use the back substitution method to find the vector of x, because that's gonna be scalar multiplication of v. Another way you're gonna see, look at this metric right there, guys. Look at this. Here is pivot column. Here is another pivot column, another pivot column. How many not pivot column is this column too, right? So that's another way to find dimension of null space, guys. So Another way, you have only one free variable right there. That's x2. So that's going to be defined dimension of null space too. Okay, so we're going to get back later, guys. Okay, let's go to second part. So how can find the dimension of a column space of A, guys? So you guys remember how gonna find the base for the column space of A? So if you review the theorem right there, column space of A gonna be pivot column. The pivot column of A gives, guys, just look it up, base for column space of A. So let's check we did the previous slides, but here is pivot column. Here is pivot column, right? Second is not. That's the free variable. We find the one free variable. This one is pivot column. Why? This one is the pivot. Another pivot column, you're going to find it right here. So how many pivot column here, right? You have find the three, right? So this one is base 1, 0, 0, 2, 1, 0, 1, 3, 1. That's gonna be basis for column space of A. So here is the dimension of a column space of A gonna be how many vector in the base is 3. So you find that. So what you can guess, previous slides, dimension of null space, dimension of color space. Previous slide, we find dimension of null space gonna be pre-variable. How many pre-variable? Just one. Here is, we are looking for how many pivot column of matrix A. That's the 3. Add together, dimension of null space A plus dimension of column space A. I think you know, already know. 1 plus 3 is 4. What is getting 4? How many column here? Here is matrix A, 1, 2, 3, 4. That's exactly number of column of A, matrix A. Let you find it, guys, okay? Let's see, I just summary here, guys. Look at this. How can find the dimension of null space, dimension of column space? So we have to reduce the matrix first, okay? Reduce row echelon form. That's the best way. That's the best way you see. Find the pivot column and pivot, right? Dimension of column is gonna be number of pivot column on reduced echelon form. Then, of course, dimension of null space gonna be number of free variable. Another way is say number of non-pivot column of REF. So dimension of column and dimension of null added together is number of columns of A, guys. Okay, that's how do you find dimension of column space, dimension of null space. Let's start one example right here. So we want to find dimension of null space, dimension of column space for given matrix. This is not law echelon form. We have to do it and to check it. This one we did previous example, right? Just to do by yourself and then check your answer with me, guys. Okay, let's do this one. This is matrix we have. Now you have reduced the rows, right? So we're gonna do it. So 1, -3, -4, 2, and 0 is pretty big. Matrix is just 3 by, here is just 3 by 5 matrix, right? So -1, 2, 6, 3, 1, 0, 2, -5, 0, 2. So you have row operation, you can guess. Division of null space, division of columns. How many columns here? 5, right? This number gonna be 5. Let me check later, guys. Okay, this should be 5, okay? Let's do the law operation right here, guys. Let's do the first one. You're gonna see this should be 0, right? So R1 plus R2 go to R2. So let's say this one. That's gonna be 1, -3, -4, 2, 0, guys, 0. Gonna be -1, 2, 5, 1, 0, 2, negative 5, 0, 2. So another you find the pivot. What is another one? Here is this is a pivot. That's right. You times negative 1, so you're gonna do there is not one way to do it, guys. Make sure negative 1, R2 gonna be R2. So you have a 1, negative 3, negative 4, 2, 0, 0, 1, negative 2, negative 5, negative 1, 0, 2, negative 5, 0, 2. Okay, so you have this one. This guy gonna be should be 0, right? So what kind of operation you need? I gonna do at the two things. This one should be 0, okay? So we have two operations together. So 3 times R2 plus R1 going to R1. Negative 2 times R2 plus R3 going to R3. So I have 1, 0, negative 10, negative 13, and negative 3. 0, 1, negative 2, negative 5, negative 1, 0, 0, negative 1, 10, and 4. Okay, you already knew, guys. Let's change this. This is pivot. First column, second column, third column. Even this one is negative 1, you can change it. Times negative 1, that's going to be changes. So you did that one. Negative 1, R3 going to R3. Actually, you don't have to, but make sure, right? Okay, guys, how many pivot column? Can you give me the number? 1, 2, 3, right? So 3 pivot column, meaning its dimension of column space A is 3. How many not pivot column? Can you see that? 1, 2. That's right. That's two pre-variable, right? So dimension of null space gonna be 2. So what is total? 3 plus 2, that's the 5.